Okay, good morning to all. Last class we have discussed regarding the syllabus and definitions. Okay, regarding the clipper and clamper. Okay, what do you mean clipper and what do you mean clamper, and different types of clippers we have seen. And before closing the session, I had mentioned a single point, a very important point. Okay, in order to understand this topic, you have to know this concept. Okay, that means what I have said. Up to now, we have studied that diode will be forward bias. Diode will be in on position or forward bias if we connected a positive terminal to the anode and negative terminal to a cathode. Okay, obviously it is right, but this definition I have changed a little bit. I am saying that whatever the voltage, okay, I am not saying that it is a positive voltage or negative. Positive terminal should be connected to anode or negative terminal to be connected to cathode. I am saying that if the anode side potential, the voltage across anode is greater than the cathode. Okay, if that means if I apply the minus 2 volts to the anode, minus 2 volts to the anode, and minus 5 volts to the cathode. Okay, I didn't follow this rule. Okay, I didn't connect the positive terminal to the cathode. I had connect. That means I may have the two supplies. Okay, in my case, I may have the two supplies. The negative of the first supply, the negative of the first supply, I have connected to the anode. Okay, the negative is connected to the anode, and I may have the another supply which may have the again negative terminal. Again negative terminal, I am connected to this side. Okay, I may have the two supplies. Okay, I may have the two supplies. I have connected in this fashion. Okay, this is having 2 volts and this is having 5 volts. Okay, two batteries. Okay, that means the anode is connected to the minus 2 volts, cathode is connected to the minus 5 volts. In this case also, okay, in this case also, your diode is in forward bias. Okay, because the minus 2 is greater than minus 5. Minus 2 is greater than minus 5. Therefore, anode voltage is greater than cathode voltage, then diode will be on. Okay, in order to make the diode on, what you have to do, you have to apply the voltage such that anode voltage should be greater than the cathode voltage. You have to keep it in mind. Okay, we should. While you are discussing in EDC, you may study like this. Okay, when you connect the positive terminal to anode and negative terminal to cathode, diode gets on. Okay, that definition I have changed a little bit. I have changed it a little bit, and I have defined that positive means it is greater voltage. Okay, the anode should be always greater potential. The anode should be always connected to the greater potential, and cathode should be connected to the lower potential. In that situation, diode will be on. Okay, therefore you have to observe that situation. We have to see that whether the anode potential is greater than cathode potential or not. Okay, if it is true, then diode is on. Otherwise, diode will be off. Okay, for explaining this point, I have taken different types of circuits and I have explained same concept. Before going into the our topic, you have to keep in the mind. Okay, when the diode is on, when the diode will be off stage. Okay, and similarly, you have to know the transistor, because you have a transistor has a transistor clipper also. Okay, you have to remember that transistor. It may be your emitter, collector, and base terminals. Okay, when this transistor is on, that means if you are taking the output here, if you are connecting the output here, simply they may mention like this. Okay, it may be connected to your ground terminal. Okay, if I connecting the output from here means what it indicates. Uh, yeah, what it indicates. If I Okay. What it indicates, if I connecting the load here means output means one terminal is connected at this point, another terminal should be grounded. Another terminal is grounded means it is connected at this point. Okay, that means this is your output voltage is connected across this here, and when this transistor is on, okay, what is the condition to make this transistor on means whenever the base current, okay, whenever you apply the base voltage greater than VBE. Here generally we may have one diode, and here we may have another diode. Transistor is nothing but a back-to-back connected diodes. Okay, if two diodes are connected back to back. Okay, then it forms a transistor. Emitter, base, this will be the base, and this will be the collector. Okay, back to back connected diode. Therefore, here we have one diode. Okay, here we may have one diode, and here we may have another diode. Okay, there are two diodes. Okay, two junctions we are going to have. When this junction, when we apply the base voltage, that means here we have the one voltage we are going to apply. This voltage, if we are applying, simply we may say that here VBB. Okay, that means the second terminal is connected here. Okay, therefore this junction has to be forward bias. When this junction is forward bias, that means VBE. Okay, if suppose if I take a silicon diode, when this voltage is greater than zero point 0.7, when this voltage is greater than 0.7, this junction gets forward bias. Okay, since transistor is a current driven device, therefore we are going to say that when we apply the base current, when we are going to applying the base current, then the transistor gets on. Okay, in order to make the transistor on, what you have to do, you have to drive the base current. When you drive the base current, transistor gets on. Okay, when the transistor is on, okay, what happens, this emitter is connected to the collector is connected to the emitter. Okay, that means we are taking the output here. Okay, when this is open, okay, that means we didn't apply the base voltage, we didn't apply the base current, then this is open. Therefore here we may have the VCC. Okay, VCC, by using VCC, entire current will flows to the output, entire current will be flows in this direction. Okay, from VCC the current will goes to the output terminal. When you apply the base signal, the current here, it may find two paths. One path is through the load, another path is through the emitter to the ground. Okay, this path is going to offering the less resistance. Therefore, entire current flows through the emitter. Okay, therefore, when the transistor is on, the output may be, I am saying ideal case. Okay, when the transistor is on, output may be a 0. Okay, a 0 volts. Okay, output may be 0 volts. When the transistor is off, from the VCC we are going to get the output. Okay, therefore transistor is a controlled switch. It can be on and off by using the base terminal. Okay, already you have done the experiment in your EDC lab also. Transistor has a switch. When you apply the base signal, your transistor is going to be on. Okay, when you remove the base signal, the transistor is off. Ideal case. Okay, practical case means there is a certain limit, because it is a diode. The current should be greater than these cut down voltages. Okay, that means you have to apply the voltage, VBB voltage, greater than 0.7. Okay, generally this current will be in microamperes. Base current will be microamperes, and collector current and emitter current will be in milliamperes. Okay, it will, these two are the milliamperes. It will be microamperes. Okay, therefore these 2 points you have to remember. Okay, in order to make the diode on, the anode voltage should be greater than the cathode voltage. This is the first point. Here this is regarding the diode. Okay, regarding the diode on. In order to make the diode on, anode voltage should be greater than the cathode voltage. I am not saying polarities. Okay, it may be a negative voltage or positive voltage, or combination of both. Okay, that means on the cathode side I may apply the positive voltage, on the anode side if I apply the negative voltage, definitely diode will be in off state. If anode side, if I apply the positive voltage, on the cathode side, okay, anode side if I apply the, that means in this fashion. Okay, on the anode side I had applied the plus 2 volts. Okay, anode side I had applied the plus 2 volts. Sorry, cathode side I applied the plus 2 volts. And if the anode side voltage also, if I apply the plus volts, that means both voltages are positive. Okay, then also you can make this diode on. Okay, when this anode voltage is greater than 2 volts, that means if I apply the 3 volts here, okay, then this diode gets on. Diode will be on. Yeah, always you have to see that anode voltage should be greater than cathode voltage. This is regarding to diode. And coming to the transistor, we have to apply the base voltage, or you have to allow the base current. Okay, when you allow the base current, then the transistor will be on. Once the transistor is on, the collector and emitter will be short circuited. Okay, collector and the emitter will be short circuited. That means the current will flow from the collector to the emitter. In this way, current will flow when you apply the base signal. Okay, if you won't apply the base signal, there won't be connection between these two. Okay, it will comes to the output. Okay, from the VCC, it is going to get output. Okay, this point you have to keep in mind. Okay, once if you keep in mind, next concept, it will be very easy. Okay, from now onwards, along with me, you can find out how the output will be. Along with me, directly, you can find out how the output will be. See, I have taken the first one, first clipper circuit. Okay, generally we have two types of clippers: series clipper and shunt clipper. Okay, in series clipper we have a positive clipper and negative. If you want to cut down the positive waveform, that means input voltage or positive pulse, if you won't require at the output terminal, if I want to cut the positive pulse, complete positive pulse means we can say that it is an unbiased clipper. It is an unbiased clipper. Okay, if I require some portion at the input side, okay, some portion at the input side, then I want to take some reference voltage. This may be my reference voltage. Below that reference voltage, I may have the output. Above the reference, I don't have the output. Okay, so that it comes under the biasing. Okay, we are getting some reference voltage, so that we are going to call it as a biasing clipper. Okay, therefore first concept is unbiased. Okay, unbiased series clipper, and also in case strictly we can say that series positive clipper, unbiased series positive clipper. Okay, has title itself, the diode should be in series. Okay, I have said that series, therefore diode should be in series with our load. Okay, this is our load resistance. Diode is connected in series. Okay, and I have said that positive clipper. Therefore, the output should not consist any positive waveform. Output should not consist any positive waveform. And unbiased. Unbiased means there is no reference voltage. Okay, when we discuss the biasing circuit, then you will get idea. Okay, keep it aside. Now we are seeing this series positive clipper. Okay, if you see the working operation of the circuit, here we are going to applying the input voltage. Here we are going to applying the input voltage. The input voltage, just as we discussed in the introduction, all these circuits will be excited by input signal only. Okay, therefore, if we apply an input signal, to this circuit, what happens? It is nothing but your halfway rectifier. Okay, when you apply the input voltage, when it is in positive cycle, you that means it may be a 0, 1, 2, 3, anything. Okay, positive 0, 1, 2, 3. Okay, cathode is connected to the positive, and the anode is connected through the ground. Anode is connected through the to the ground. Okay, therefore, and on the anode side you have the voltage is ground means 0 volts. Okay, anode is 0 volts, and cathode should be less than the anode voltage. If we apply negative voltage, then the diode will be on. Okay, but we are in positive cycle. Therefore, it is 1, 2, 3, 4. It may be a positive values. Therefore, here it may have in positive voltage on the anode side. Therefore, diode will be in reverse bias. Diode is reverse bias means it is an open switch. Okay, here there is no connection. It is an opened. Okay, therefore if it is open, we won't get any output. Okay, therefore output is 0. In positive cycle. Okay, output is 0 in positive cycle. Okay, when the input changes to negative cycle. Okay, when the input since it is sinusoidal, when you are getting the negative cycle, here on the cathode side you are getting -1, -2, -3 volts. Okay, we are getting a negative voltage on the cathode side. Anode is 0 volts. Anode is at 0 potential and cathode is at negative potential. Therefore, anode is greater than the cathode potential. Anode is having the greater potential than cathode. Therefore, diode is in on state. Therefore, diode will be in on state. Okay. Therefore, diode is on means it is a closed switch. When the diode is on, it is a closed switch. Okay. Somebody has unmuted their mic. Okay, no problem. I will mute. I will mute you all the participants. Yeah, if you have any doubts, please raise the hand. Okay, in settings you may have the raise the hand. Because your mic may not be working now. I am making it as mute. Okay. Okay, when coming to the negative cycle, it is a negative voltage is applied across the cathode and 0 volts across the anode. Therefore, this diode will be in on state. Okay, when this is on state, it may act as a short circuit. Okay, I am speaking regarding the ideal diode. Okay, if it is a practical diode, you may have some cut down voltage 0.7. Therefore, output may start after 0.7. Therefore, diode will be, we suppose if it is a minus 0.7, okay, somewhere here you may have the minus 0.7, and you may have the output after minus 0.7. Like this, you may get it. Okay, like this you may get if it is a practical. Okay, because definitely there will be some cut down voltages. Okay, I have drawn for a practical ideal diode. Okay, it is not a practical, ideal diode. Therefore, diode will be switched on at 0 volts. Okay, therefore, when we apply the negative cycle, diode gets forward bias and going to act as a short circuit. When it is short circuit, whatever the input voltage, that will be occurs across the output terminal. Therefore, on the output side, you are going to get the only negative pulses. Okay, for the positive pulse, your diode will be in off state. Okay, diode will be in off state. Okay, I think so. You are clear with this concept. Okay, a simple concept. When this diode is on, that's why I had said previously only. You should remember that when the diode will be on. In this case, anode voltage is 0. So because the anode is connected to the ground. Anode is connected to the ground. Therefore, anode is at 0 potential. Anode is at 0 potential. When the cathode applying the negative voltage, diode will be on. Less than 0. Less than 0 means negative voltage. We have to apply the negative voltage to the cathode. When you apply the negative voltage to the cathode, diode gets on. If we apply a positive voltage to the anode, diode will be off. Therefore, in positive cycle, diode will be off, and in negative cycle, diode will be on, and we will be getting the output. Output is collected across here, across the resistance. We are going to collecting the our output, and here we are going to applying the our input. Okay, the same matter I had explained in theory. Okay, whatever we have discussed up to now, the same thing I had I had written in theory point. In positive cycle, what is going, and negative cycle, what is happening. Okay, once go through this matter. Okay, this is regarding to your series clipper. Okay, circuit diagram and output waveform. Okay, we may have one more concept, that is transfer characteristics. Regarding this same concept, we will discuss it later. Okay, up to now we have seen the input waveform and output waveform only. Okay, while coming to the next concept, that is we have seen series positive. Therefore, next concept will be series negative clipper. Okay, series negative clipper. That means it is a negative. Negative means we have to clip the negative portion. Okay, we have to remove the negative waveform. Output should consist only a positive waveform. Therefore, the diode gets reversed here. If you observe, only difference is diode is reversed. Now, your cathode is connected to the 0 potential. Okay, your cathode is at 0 potential. Anode is connected to the input voltage. Anode is connected to the your input terminal. When the input voltage is positive, that means when it is 1, 2, 3, 4, so on. Okay, when it is in positive cycle. Okay, when it is in positive cycle, your diode will be in on state. Diode will be in on state. Okay, therefore, when diode is on, we may get the output. Okay, we are going to get the positive cycle. Okay, actually, there should not be this gap also. The output will be like this. Okay, you may have the positive cycle. You may have the positive cycle. When you are getting negative cycle, when you are in negative cycle, here you may having negative voltages. Okay, if the cathode is in 0 potential, anode is less than 0, therefore diode is reverse bias. Therefore, you may get a 0 voltage across the output terminal. Okay, 0 voltage across the output terminal in negative cycle. Again, if you get a positive cycle, again you are going to get the output. Okay, therefore, like this you may get the output terminal. Okay, as similar to your series positive clipper, only changes here we have reversed the diode. Okay, we have reversed the diode. Therefore, it is converted into a negative clipper. Okay, I think so. You are clear with this concept also. Very simple. You have to explain what will happen in positive cycle and negative in examination. Why I had written these points means in examination you have to write like this. Okay, you have to draw the input waveform on the circuit diagram, output waveforms, and you have to explain what happens in positive cycle. I had explained in very briefly. In an examination, you can write one or 2 points more. Okay, very briefly I have explained here. Okay, you have to write like this. Okay, in positive cycle what happens and negative cycle what happens, and next we will see the transfer characteristics also. Okay, so that you may get, this is your first point, this is second point, third point, and fourth point is your transfer characteristics. Okay, Therefore, for every topic, you may have the 4 points. Okay, 4 points you have to write it compulsory. Okay. Next we will see we have completed the series clipper. Next we go for the parallel clippers. Okay, parallel clipper. Okay, it's same fashion. Okay, the only difference is diode should be in parallel with your output. Okay, a diode should be diode should be in parallel with your input. Okay, diode should be in parallel with your input. Okay, when it is in parallel, okay, this is not load resistance. This is current limiting resistance. Okay, because when the diode is on, here you are getting a short circuit. Therefore, when you make a short circuit across the input, okay, it may damage your circuit. Okay, because if you make a short circuit, high amount of current will be flow. To limit this current, we are using a current limiting resistance here. Actual output will be here. Okay, this is your load resistance RL. Okay, here this is your load resistance. Okay, this is not your load resistance. Previously we won't find this resistance. Okay, previous case we won't find, because since the diode is in series. Okay, when you make a short circuit your diode, load comes into picture. Okay, now if you make a short circuit, the load is also get short circuited. There is no load also, because this finds the shortest low resistance path. Total current will flows through this diode and diode gets damaged. Okay, therefore in order to limit that one, in order to limit the short circuit current, we will place a resistance in series with the supply. Okay, therefore this is nothing but a current limiting resistor. Okay, it is going to use to limit the current. Okay, whatever may be, the diode is in parallel with our supply voltage. Therefore we are going to call it a parallel positive clipper or shunt. We have another name for parallel, we may call it shunt clippers. Okay, a shunt positive clipper. Okay, since here we are not using any reference voltage, we are going to call it as an unbiased clipper. Okay, it is an unbiased shunt positive clipper. Since it is a positive clipper, we have to cut the positive waveform in the input cycle. We have to cut down the positive waveform in the input cycle. Okay, therefore output should not consist any positive cycle. Okay, here also same fashion. This is grounded. Okay, this is grounded. Therefore, the cathode of your diode is connected to 0 volts. Cathode is connected to the 0 volts. When the anode is connected to the greater potential, that means greater than 0. Greater than 0, when anode is connected, then diode will be on. Okay, when the diode is on, you are collecting the output here. Therefore, across short circuit, if you make a voltmeter, what will be the voltage across short circuit? The voltage will be 0 volts. Okay, therefore when the diode is on, the output gets 0, because we have make a short circuit here. Diode is on means it is short circuited. Okay, once it is short circuited, the output will be 0. Okay, across short circuit the voltage is 0. Okay, if it is open circuited, whatever the input, that will be occurs across the output. Okay, whatever the input, that will be occurs across the output if it is opened. Okay, therefore since the cathode is connected to the 0 potential, so whatever the voltage, okay, greater than 0, whatever the voltage greater than the 0, we are going to get across the output. We are going to get across the, or we are going to get 0. Okay, once again I am saying, since the cathode is connected to 0 volts, it is connected to 0 volts. If the input is in positive cycle, if the input is positive, anode voltage will be 1, 2, 3, so on. Okay, it is a positive voltage. Therefore, diode is in on state. Once it is on, here we are going to get a short circuit. Once it is short circuit, the input will be goes in this direction. Okay, because here the current is two paths. One path is through the diode, another part is to the load resistance. It is load resistance having some impedance. Okay, here this is a short circuit path. In this path we are going to having the less impedance. Therefore, entire current will tries to flow through the low resistance only. Therefore, total current flows through the diode and makes the ground. Okay, and goes to the ground. Okay, therefore, whatever the current flowing through the diode, it will get to grounded. Okay, therefore the output is 0. We won't get any voltage, any current through this resistor, and we are going to get output has 0 volts. Okay, if we are applying a negative voltage, okay, that means negative cycle. When you are getting a negative cycle at the input side, when the input is negative cycle, okay, on the anode side we are getting -1, -2, -3 volts, because it's a negative cycle. Okay, we are getting minus voltage, and cathode is at zero potential. Cathode is at zero potential. Therefore, diode is in reverse bias. Why diode is in reverse bias? Anode is having less voltage than cathode. Okay, anode having -1, -2 volts. Cathode is at zero. -1 is less than zero. Therefore, diode will be in reverse bias. Diode will be in reverse bias. Since it is a reverse bias, here we are going to get the open circuit. This will be open. Okay, the diode will be open. Therefore, this branch will be open. Therefore, current flows through the here. Okay, what are the input? We are going to get at the output terminal. What are the input? The entire input will be gets at the output terminal. Therefore, the output in positive cycle we may have the zero. In negative cycle, whatever the input that we are going to occurring at the output terminal, that we are going to see at the output of your load. Okay, therefore this may be your output cycle, output waveform. Okay, this is regarding to your shunt positive clipper. Shunt positive clipper. It is cutting the positive waveform. Okay, since it is mentioned in dotted lines, it is your input waveform. Okay, this is your input. Okay, this dot line is your output. Okay, this is your output. Okay, this portion we are going to cutting. We are going to cutting this portion. Okay, in positive cycle we are getting a zero. We are getting zero voltage. In negative cycle, whatever the input, same we are going to getting as the output. In positive cycle, again we are getting a zero output. Okay, this is our input waveform. Therefore, this is regarding to your positive clipper. Okay, regarding your positive shunt positive clipper. Okay, it is cutting your positive waveform. Okay, we will see the shunt negative clipper. Shunt negative clipper. Simply reverse of the diode position. Reverse of the diode position. Okay, in this case, the anode is connected to the zero potential. Anode is connected to the zero potential. Okay, anode is connected to the zero potential. Therefore, when you apply the positive voltage, when you apply a positive voltage, okay, what will happen? Anode is at zero potential and cathode is going to having the 1, 2, 3, 4, so on positive voltage. On the cathode side, you are going to having the positive voltages. Okay. On the cathode side, if you are having a positive voltages, diode will be in off stage. Okay. I think so you are understanding what I am saying. Anode is connected to the ground. Anode is connected to the ground. Therefore, here you may having the 0 volts. Okay, I will take the pen. Okay, here you may have the 0 volts. Okay, when you are applying a positive cycle, the positive voltages, that means 1, 2, 3, 4, so on. Okay, the positive voltages will be occur at the cathode side. Okay, since the cathode voltage is greater than the anode, this cathode will be in off state. This diode will be in off state. Okay, therefore, for a positive cycle, diode is act as an open switch. Diode is going to act as an open switch. Diode is in off state. When it is off, it is going to act as an open switch. Okay, if it is open switch, what are the input? That input will be goes to the output. Okay, the input will be comes to the output. Therefore, the positive cycle you may get at the output terminal. The positive cycle you are going to get at the output terminal. Okay, when you are applying a negative, when you are applying a negative cycle, the cathode, okay, cathode is having the negative voltages. Cathode is having the negative voltages and anode is at zero potential. Okay, therefore cathode having less voltage than compared with the anode. Okay, on cathode side you may have -1, -2. You may have the negative voltages. Okay, on the anode side you are going to having the 0 volts. Therefore, cathode is having less voltage when compared with the anode. Okay, anode is at zero potential and cathode is at negative potential. Okay, therefore 0 is greater than the minus. Okay, therefore this diode will be on. When it is on, here you are going to get a short circuit. Here this diode will be short circuit, and whatever the input that will flows through this branch, through this diode, and gets grounded Okay, therefore we won't get any output. Therefore output will be 0 in negative cycle. Output will be 0. Output will be 0 in the negative cycle. Suppose this may be your input, or output may be 0. Okay, you won't get any output at the output terminal. Therefore, this is your parallel negative clipper. Okay, this is regarding your parallel negative clipper. Okay, now we will discuss the transfer characteristics. Okay, previous concepts. Okay, we will see the new concept, that is transfer characteristics. while seeing this diagram, you may get confused. Okay, what is these lines or all? That is nothing but a transfer characteristics. I am going to define the transfer characteristics as transfer characteristics is nothing but a graph drawn between the input voltage and the output voltage. Okay, I think so. You have studied in your two ports. Two port you may have the transfer impedance. Yeah, you may find the word that Z21, okay, Z21 and Z12. Okay, it is the ratio of output by input. Okay, yeah, if we take the Z21, okay, Z21, okay, I think so. You have remember the two-port network in our network. Z21 is nothing but the output voltage by input. You may take output voltage V2 and input current. Okay, input current. One is output parameter, one is the input parameter. Therefore, we are going to call it as a transfer impedance. Okay, we are going to call it as a transfer impedance. Okay, otherwise, if you want to remember, no problem. Transfer means transfer characteristics or transfer impedance. If you find this one, we are going to take the input and output parameters. Okay, relation between the input and output. Okay, that is nothing but a transfer. Okay. Therefore, we may find this word in our networks or in some other subjects also. If this word came means it gives the relation between the input and output. Okay. For here also, we are going to draw the relation between the input and output voltages. Okay. This is your transfer curve. Okay. This is your transfer curve for a positive shunt. Okay. For a positive shunt clipper. Okay. I have considered here. I have written the name as with zero reference voltage. Zero reference voltage means there is no reference voltage, okay, which we have seen previously. Okay, I can mention the name anyway. Okay, in exam they may ask anyway. Okay, explain a positive shunt clipper with zero reference voltage. Otherwise, they may ask the explain unbiased shunt positive clipper. Okay, they may ask in that way also. Okay, you have to prepare. Okay, zero reference or unbiased, both will give the same meaning. Okay, therefore here I have written the name as with zero reference voltage. Okay, this is nothing but a unbiased clipper. Okay, unbiased clipper, and it is a positive shunt clipper. Positive shunt clipper means that the diode should be in shunt. That means diode should be in parallel. Okay, diode should be parallel with the input, and if it is a positive, therefore the output should not consist the positive waveform. Output should not consist the positive waveform. For this one, if you want to write the transfer characteristics, how you are going to draw? See, here I have taken the practical diode. I have taken the practical diode. This is my input line. Okay, this is my input line, and this is my output line. Okay, this is my input voltage. X-axis is going to representing the input voltage, and Y-axis is going to representing the my output voltage. Okay, therefore this is my input voltage. Okay, here I have taken X-axis, and this is my input waveform. Okay, and this is my Y-axis. Okay, Y-axis I have drawn the input cycle. Okay, therefore in positive shunt clipper. Okay, in positive shunt clipper, our cathode is connected to the zero potential, and if the arrow is positive, so that means in positive cycle what happens? In positive cycle, diode gets short circuited. But here I have taken a practical diode means, if suppose our input voltage, our input is a sinusoidal which is varying from zero slowly to some maximum of 5 volts. Suppose if we take like this, when the input is at 0.1, when input voltage is at 0.1, our input voltage is 0.1. This is if I take it as a silicon diode. When the input is 0.1, silicon diode cut down voltage is 0.7. Yeah, that means before 0.7, already you know the diode characteristics. You have seen in your EDC also. Like this you may get. Before 0.7, you may have output may be 0. You won't get the output. Diode is in off state only. Okay. Therefore, when you apply a 0.1 voltage, diode is off. When you apply the 0.2, diode is off. And so on. When you apply the 0.6, diode will be in off state. Okay. When you apply the 0.7, then the diode will get short circuited, and we are going to get the output. Therefore, if we observe the transfer characteristics, then what about your output? Okay, your output voltage, when diode is off means whatever the input, it will get at the output terminal. If we apply the 0.1 volts as the input, If we apply the 0.1 at the input, output is 0.1 because diode is in off state. When we apply the 0.2, output will be 0.2. Output will be 0.2. When we apply the 0.6, output will be 0.6. I think so you understand what I am saying. Okay, because our input voltage is slowly increasing. Okay, it is slowly increasing waveform. Okay, it is a sine wave slowly increasing. Therefore, when 0.1, 0.2 up to 0.6, the diode will be in reverse bias and we are going to get the output. Therefore, the output also slowly increases as the input increases. This is the input axis. Okay. Therefore, as the input increases, output also slowly increases. Output also slowly increases. Okay. When it reaches to 0.7, that's why I have mentioned as V gamma, cut-in voltage. V gamma is nothing but a cut-in voltage. When I have reached to 0.7, diode gets on. Diode gets on. Okay. Once the diode is on, entire input will flow to this side. Therefore, the voltage across this diode will be a 0.7. Okay. The voltage won't increase greater. Okay. Therefore, the output will be maintained constant. Output will be maintained constant. Okay. It will be at 0.7. Previous case we have taken ideal case. The output is maintained at 0. Okay. When it is positive cycle, the output is 0. We have taken an ideal case. Okay. When you are getting into practical case, output may rises up to 0.7. Output may rises up to 0.7. After 0.7, diode gets on. Therefore, we are going to maintaining a constant voltage. Similarly, okay, this is our output waveform. Okay, our sine wave has increases up to 0.7. Okay, up to 0.7 it has increases and then it is maintained constant. Above the 0.7, we have clipped the output waveform. Okay, we had clipped the input waveform. We won't get this waveform. We won't get this waveform whatever the greater than 0.7. Okay, greater than 0.7 we are not getting. While coming to negative cycle, if we apply negative voltage, diode will be reverse bias. Therefore, whatever the input, that will get the output. Therefore, output will be increases linearly. As the input increases, output gets increases. Therefore, whatever the input, the same output we are going to get. Okay. Therefore, this waveform which we have seen previously, this is your transfer characteristic. This one you have to draw it. Okay. Transfer characteristics of a first shunt clipper. Okay. Transfer characteristics is nothing but the output versus input. Okay. On x-axis you are going to take the output, on y-axis you have to take the output. Okay. X-axis input and on y-axis output. Once again, I explain the transfer characteristics. On the y-axis, we are going to draw your output voltage, and x-axis, you are going to draw the input characteristics. Okay, similarly, okay, this is our x-axis and this is our y-axis. Okay, we have drawn our input waveform. Okay, our input waveform. As the input is increasing, up to cut down voltage. Okay, this may be our cut down voltage. I have drawn the line. Okay, up to this point, our output also increases because our diode is in off state. When it when our input voltage is reaches greater than cut down voltage, diode gets short circuit. And output will be maintained constant. Okay, output will be maintained constant. In negative cycle, diode will be reverse bias. Therefore, the input will be comes to the output. Therefore, output will be linearly increases. Here also similar fashion. Okay, this waveform which we have drawn previously, but previously you have taken as idea. Therefore, here we have mentioned the zero voltage. Okay, zero and negative cycle. Like this we have drawn. Previous case. If I take a practical, then we may have a output maybe up to the cut down voltage 0.7. Up to 0.7 diode we won't get. If it is a silicon, if it is a germanium, the voltage may be 0.3. Okay, your diode will be switch on at 0.3. Okay, 0.3 volts diode gets on. Okay, therefore transfer characteristics I have drawn both the ideal and practical. For next topic also I will explain only the practical case. This is the first case. That's why I have written both for the ideal and practical cases. Okay, if it is an ideal diode, output will be 0. If it is ideal, okay, there won't be any cut down. When the input is greater than 0, okay, sorry, this may be your input. This is your input. Okay, when the input is greater than 0, that means in positive cycle. Okay, this is connected to 0. Oh, sorry, I have written a mistake. I think so. Reverse I have written. Okay, this may be your VI. Right. Once again, see what I have written here. I think so. I have done a mistake here. whether it is right. When the input voltage is greater than 0, that means in positive cycle. Okay, when input is increasing linearly. Okay, cathode side is connected to the zero potential. It is zero potential. Output, okay, has the input is increasing linearly. Okay, that means 1, 2, 3. Diode, okay, right only. Okay, diode is on. Okay, in this case, diode will be on. Diode will be on. Okay, when diode is on, output will be zero. Okay, when diode is on, output will be zero, because here we are getting a short circuit. Okay, when the input voltage is greater than zero, diode gets on. Diode gets on, and the diode gets on means our output voltage will be zero. When input voltage is less than zero means here we may have -1, -2. This terminal will be zero. Therefore, diode will be off. Diode will be off here. Okay, diode will be off. When it is off, we are going to get the input voltage. If it is a practical diode, the when the input voltage is greater than cut down voltage, only, then only diode gets on. Okay, it won't be on at zero. Okay, when the input voltage is greater than cut down voltage, diode will be on, and output voltage will be maintained constant at cut down voltage. Output is, you can see in transfer characteristics. Okay, output voltage will be maintained constant at cut down voltage. Okay, when the input voltage is less than, okay, when the input voltage is less than cut down, diode will be off. Okay, diode will be off, and whatever the input, we are going to get at the output terminal. Okay, this may be your practical. And this may be your ideal. Okay, this is regarding your transfer characteristics. You have to, if suppose in exam they may ask you to explain about positive shunt clipper means, you have to you have to explain the circuit diagram, you have to draw the output waveform, and also you have to explain the transfer characteristics also. Okay, I had to explain transfer characteristics separately. Okay, you have to write the transfer characteristics, output waveform, and you have to explain the diagram also. Okay, circuit diagram. In positive cycle what happens, and negative cycle what happens. Okay, everything you have to explain. I think so you are clear with this concept. We will meet again in 4th hour. If we have any doubts regarding today concept, we will discuss it in the evening hour, 4th hour. Okay, we will discuss it at 4th hour. Okay, join for next class. Okay, join for next class by 9:55. Okay, thank you.